Okay, hi. I just got this email here from Craig, so I'm going to leave this, and I thought I would do something about it. So here we go. Stretches and reflections. This is going to be about 10 minutes long. So take a look at this. When we talk about any function, just like we were talking about yesterday, we say that y equals f of x. The output is something done to the input. And we're going to change this. We're going to find new y's by doubling f of x, by doubling the outputs. And that's going to result in vertical stretches or compressions if the number 2 here happens to be smaller. If this number 2 is smaller than 2, let's say if it's a number like, if it's a number like 1/2, then that's going to be a compression vertically. If it's a 2, then it's going to be a stretch. When we look at this, this is affecting x coordinates of our function, and this is actually going to do the opposite of what you think. Instead of stretching horizontally, making it bigger horizontally, this is actually going to compress. And if we replace that 2 with something like 1/2, then that's actually going to shrink it. That's going to stretch it horizontally. We're going to look at why that is in a second. So there's that. And then we're going to quickly look at these flips. Reflections. Now there's 3 types of reflections. The third one is an inverse, and we're not going to talk about the inverse function today. So very quickly, if we go back to looking at the graph sine x, you may recall that if we put in the graph sine 2 sine x and take a look at what that graph looks like, you'll notice that the x coordinates have not changed. By sticking that 2 in front, all we've done is change the old y coordinates of the function into new y coordinates. So I might be able to zoom in here so that you can see that a little better. Yeah, we've managed to enlarge that a little bit. So the black function is sine x, the red one's 2 sine x, and what we've done there is stretch vertically by changing the y coordinates. If I take that 2 sine x out and instead put the 2 here multiplying the x, you'll notice that the maximums have not changed. The red and black maximums and minimums are exactly where they were. The y-coordinates, the range, is unaffected. The domain, however, is. Here I had half a wave between 0 and pi. Now I'm going to get a full wave between 0 and pi. So when you stick the 2 out front, what you're doing is you're changing the y-coordinates of the function. The x-coordinates don't change, so you just find a few key points on your graph and take the old y-coordinates multiplied by 2. That's what that 2 out front does. If you're multiplying your x-coordinates by 2, then you're actually compressing. So you're not going to multiply your x-coordinates by 2. You're actually going to multiply by the reciprocal of 2, which is 1/2. So that's counterintuitive, and you have to remember that little tricky bit. Let me go on and show you again by taking a look at this function here. So here we have, let me change that up. Here we have a function y equals f of x. So I'm changing that up because I don't want the negative sign there. What if we want to change it so that it's not y equals f of x, it's y equals 2f of x. So I've preset this a little bit, and like I said before, all we're going to do is, I think I've lost all of my presets. So this is going to be interesting. We're going to pause the recording, and then we're going to start right back here. We're going to start right back here and continue once I get my presets set. Okay, all set and ready to go again. So here we are. We were talking about what happens when we change the y-coordinates, when we multiply our y's by some value. So I'm going to show you. Minimize this and go back to our graph. So there's our original function. Now we want to change y equals f of x to y equals 2f of x. And what that 2 means is that we're going to double all the outputs. So if you look carefully, you'll see that the bottom horizontal line lives between at y equals -2. And it lives between x equals 0 and x equals 2. The y-coordinate is doubled to -4. The top horizontal line lives between x equals -4 and -2. The y-coordinate is 2, so if you double the y-coordinate, that 2 becomes a 4. And so what we're going to do is, that's it. That's what the new graph looks like. So we've doubled that bottom black horizontal line living at -2 is now at -4. X-coordinates don't change. The x-coordinates where all these interesting turning points happen stay the same, including the endpoints. But the y-coordinates have changed, and by finding the coordinates of the endpoints from the far right-hand side to that first turning point on the y-axis, up towards -2, 4, and then to the endpoint on the left, those are kind of the important points for this curve. And so I would find the new coordinates from the old ones, looking at the same endpoints on the black graph, by just multiplying the y-coordinates by 2. And that's how I'd get the green graph. Okay, so that's what happens when we do that. But now the question is, what's going to happen when we don't multiply the y-coordinates by 2, but we multiply the x-coordinates by 2? Now, I've already explained this a little bit when we were talking about the trig functions. And again, here's my preset, and you can see the test that's coming. And this is what happens when now you'd expect it to stretch, but it doesn't. Now this one, the y-coordinates are going to stay the same, but the x-coordinates will change. So notice that the y-coordinate of +2 and the y-coordinate of -2, that's still the same. But that endpoint at -4, that's moved. Half of -4 is -2. The endpoint here at -2 becomes -1. And similarly down below, the endpoint at 2, -2, the x-coordinate changes to 1, -2, and the original point you see on the y-axis is unchanged because its x-coordinate is 0, and anything times 0 remains unchanged. So what did we multiply our x-coordinates by? Not by 2. We didn't multiply them by 2. What we actually multiplied them by was the reciprocal of 2, 1/2. So if you want to see in more kind of concrete terms exactly what happens, get out your graphing calculator and start by graphing this function, y equals the square root of 4 minus x squared. And then if you want to see what happens when you do something like this, when we double the outputs, then what we'll do is we take this graph and just stick a 2 in front. You're multiplying that whole function by 2. Look at that graph. Look at which coordinates have changed, x coordinates or y coordinates. So you have to look on your calculator to see what's happening here. I won't show you because you need to do some of this yourself to really understand it. Now, the next thing that we want to look at is what happens if we change the x-coordinates, like this one. Well, again, we're going to go back to this graph, and instead of putting x, you're going to put 2x, and notice how I've got that in brackets. So make sure you respect those brackets when you're entering that into your calculator. Again, enter it in your calculator and see what changes, the x-coordinates or the y-coordinates, and it'll probably become very obvious to you. Look in particular at the intercepts, x-intercepts and y-intercepts of the graph. Now when you're doing this, make sure that you use a zoom 4 window when you do that. Use a zoom 4 window to take a look at that. So we've seen stretches and vertically and horizontally. Now the only thing we didn't do is use negative numbers. If I wanted to compress something vertically instead of a 2, I would stick in a number here like 1/2, and then it's going to be smaller vertically. I'd multiply all the y-coordinates by 1/2. If I wanted to change my x-coordinates, and this one is compressing the x-coordinates, if you remember, it's the opposite of what you think it would do. If I wanted to stretch it, then I would multiply by 1/2. The reciprocal of 1/2 is 2, and so that's how we would find the new x-coordinates. So remember that as well. Play with that as well when you're exploring this function in your calculator. See what happens if you stick a 1/2 in here. And again, when you do that, put in brackets and respect those brackets carefully. Notice how I've done that. Okay, that's how you're going to want to enter that on your calculator. You're also going to want to see what happens if you didn't put a 2 there, what happens if you put something like 1/2 out in front. And if you do that, do it by inserting a pair of brackets in front and multiply it this way. That's how I want you to enter it in your calculator. Okay, so going back to our we're going to take our function, and instead we're going to say y equals f of x. Now I'm going to take this preset, and that's what I was showing you what happens when we compress along the x-axis. That's what f of x equals y equals f of 2x. And the question is, what's this function going to look like? So let's go take this guy and put him on the graph, and let me paste him in. and I want you to tell me what's happened to this fellow. So let me get him on the graph because he's giving me a bit of a hard time at the moment. Let's see. Yeah, that's the transformation. I'm going to change the color of that particular graph so that we can distinguish it from the original, and set the transparency. And so, oh, that didn't work. Let's try it one more time. If it doesn't work, you get the idea. What I'd like you to do is I'd like you to figure out what is the new equation for that. Oh, here we go. I forgot to press OK. So I'd like to know what is the equation for this graph, the blue one. So it's going to be, there's my original, and the new one is going to be what? It's going to be y equals, now at this point I'm going to put the answers, so pause the video and then check your work against mine. Here's the answer. If we look carefully, we've seen that the y-coordinates have changed. The old y-coordinates lived at 2 and -2. The new y-coordinates are at 4 and -4. They've doubled, so it's a 2f of x. Now if we look carefully at the x-coordinates, this x-coordinate is unchanged, but this 2 has become a 4. This 2 has become, this -2 has become a -4. I'm looking at the x-coordinates. And this -4, this final endpoint, is now at -8. They've doubled. So that means that what I've got in here is 1/2, and the smartboard software won't let me write fractions properly. So that's what it's going to look like. And that's actually what it will look like when you enter it into your calculator if you were to do such a thing. Showing you the way you're really supposed to write that. The way you're really supposed to write it is this. So what we saw, if we go flip back to the graph, actually why don't I just take this over, we'll throw that into our whiteboard, and this is our answer right here. So I can get rid of this. And again, why is that the answer? Because the y-coordinates have doubled and the x-coordinates have also doubled, which means the coefficient of x is multiplied by the reciprocal of this number in front of the x. And the reciprocal of 1/2 is 2, and that's how we got them to double. I'm just going to quickly finish up. So I'm going to take this, and I'm going to take my blue graph over here, take these guys, get them out of here, and we're going to quickly talk about reflections. And here we go. So that means reflections. What do I mean by that? That means when we have negative numbers involved in this. So that instead of y equals f of x, it's y equals negative f of x. And again, it's the same thing as we were talking about back here. I'll change this back to our original. Remember how this is multiplying the y-coordinates. So if we come back to this, that negative is multiplying the y-coordinates. Looking at your graph, only the y-coordinates will change. The x-coordinates won't change, and you're multiplying them by 1. We think of that as a -1. So 2 stays 2, but instead of +2, it becomes -2. And these y-coordinates, instead of being -2, will become +2. So essentially, what happens, and I'm going to just use a feature here on the smartboard to show you, it flips. It flips up and down. It flips over the x-axis. Multiplying the y-coordinates by 1 ends up flipping it over the x-axis. There's the original. And there's what happens when you flip it over the x-axis. You're changing the y-coordinates. Again, the original, and we flipped it over the x-axis. So what happens if that negative is not there? What if we multiply the x by a negative? And we get f of -x. What's that going to do? Well, again, we're not changing the y-coordinates. That's going to not change. It's only the x-coordinates. And we're multiplying them by 1. So the values aren't really going to change, except positive values will become negative. So this has an x-coordinate of 0. It's not going to move. It's still going to be on our new graph. This x-coordinate is at 2. When I multiply it by -1, it's going to live over here at -2. And the top horizontal bar is also going to get flipped over. So let me show you very quickly by using the draw command, and it's just going to be a horizontal flip over the y-axis. And that's what that did, having the negative. Again, here's the original, and when I multiply the x-coordinates by -1, the graph doesn't change any y-coordinates, only the x, and they just flip. Oh, oops. It didn't quite flip over the x-axis. It should be, sorry. And there I was all proud of myself. The other one's good. This is what this one looks like. So there's my flip over the x-axis. Again, because I knew that I was wrong, because if you multiply 0, this x-coordinate, by any number, it still has to be 0. That's how I knew I had made a mistake there. So again, let me take that, and we're going to flip it. This flips it not over an axis, it flips it over its center, and that's why we were getting that error. So here's my original graph, remember, had looked like this. That's the original graph. And when I multiply all my x's by -1, it's going to flip horizontally, so that the x-coordinates, that y-intercept is going to stay the same, and the right-hand endpoint will be at -2. And this, instead of being at -2, -4, that's the top horizontal bar, will go from +2 to +4. So again, if I flip it left-right, and then I got to move it over to make sure that it respects the coordinates properly, that's the horizontal flip. That's what happens. And that, ladies and gentlemen, concludes this lesson on reflections. Now, there's a third type of reflection called an inverse, and we'll look at that in class on Monday. Take care. Have a great weekend.